Assalamualaikum and hi everyone. Today I will discuss about integration by parts. First of all is learning outcomes. What we can learn from this topic. Firstly, students will know to decide when it is appropriate to use the method as integration by parts. Next, how to use the formula for integration by parts. Third, students also will know the order to choose which function first to be used when have make function. And lastly, apply the application integration by parts in real life. How do we know to use or apply integration by part? Integration by part can be used when two functions are multiplied together. And when we do substitution, it doesn't work. The formula of integration by part can be obtained as integration fx g prime x equal to fx gx minus integration f prime x gx. But we usually write the formula using the following notation. We can substitute u equal to fx, v equal to gx, du equal to f prime x gx, and dv equal to g prime x dx. By using substitution rule, this formula can be written and comes integration u dv equal to uv minus integration v du. When we apply to use integration by part, we have to make a suitable choice to u and dv. There is a strategy to choose u and dv. First strategy is, for the function u is usually more easy to do differentiation, and for the function dv is more easy to do integration. There is the table of priority in choosing u that we can remember. First one is logarithmic function, as example log x or ln x. Secondly, polynomial function, as example x square or y cube. And thirdly, exponential function, as example e the power of x or 6 the power of x. And lastly, trigonometric function, as example sin x or cos x or tan x.
Assalamualaikum warahmatullahi wabarakatuh dan hi. My name is Shahmin and I will tell about the application of integration by parts, or known as IBP, in real life. So let's go. Okay. Alright, about the basic about the integration by part. First of all, we must try to use substitution first. If we cannot reformulate the function into the correct form, then we can try to use integration by part to solve the integration. Alright, this is the integration by parts formula. Alright, about the application that we can use integration by part is to calculate the initial acceleration of a plane before takeoff. Okay, this is the plane that's already take off. Okay, this is the graph of the plane. This the velocity versus time. Okay, a study was done to study the acceleration required for an airplane to take off from an airport. From the graph, the function for the initial acceleration can be expressed as y equal to x e power of x, right? This function is for point A here to point B, the initial acceleration. Right, the meaning of initial acceleration, right, is it was the speed the speed that the plane needed to to start to take off from the real runway. Right, at point B to point C is after the plane start to moving upward, which the tire of the plane already did not touch the ground, and go at point C, the plane already at the mid altitude, so that the plane can start moving forward. Okay, C to D is the terminal velocity, which is the plane already at the static altitude like that. Then the plane can start moving forward until they reach the destination. Okay. Okay, if we look about this equation, this function, right? Y equal to x e power of x. You might be thinking, why we cannot solve it by using basic integration, right? But no, you are wrong. Because this is the most hardest for us to solve it. So that we must use the formula of integration by parts, which is integrate u dv equal to uv minus integrate v du. Alright, we use this integrate here, integrate this function, right? Alright, the u is x and dv is this e power of x. Alright, du equal to this x, which is we differentiate this x and we get 1 dx, and vex, alright, we write it down too fast. Alright, this u, which is x, right, dear x, don't wrong, and v is e power of x, we write it down, right, here v, right, then we minus integrate here, minus integrate, and then v is where? Here, v equal to e power of x, which is, v power f is 1. Too fast. Alright. Sorry. Okay, I'm sorry. The e power of x is in front. I'm sorry. V e power of x, and the back one is du, which is 1 dx. Maybe this slide. Okay. It's okay. Okay. After this, we can solve it easily by using basic integration. Alright, that's all from me. Thank you.
This question, we were required to find the integral by using integration by parts. So, when we want to use integration by parts, we first need to determine our u and v. To choose our u, we need to refer to this sequence. First need be logarithm, polynomial, exponential, trigonometry. So since we have polynomial and trigonometric, so we will let our polynomial to be our u. So our u is equals to x square. When we differentiate our x square, it will be 2x. And then our dv over dx will be cos x. When we integrate our cos x, it will be sin x. Integrate u dv dx equals to uv minus integrate v du dx is the general form of integration by parts. Now, based on our question and what we found, we need to substitute everything into this general formula, and we will have integrate x square cos x equals to x square times sin x minus integrate sin x 2x. And then now we're going to move on to the calculation. So x square sin x minus integrate 2x sin x. Now at here it's involve another integration of polynomial and trigonometry. Therefore we need to do integration by parts separately for this. Okay, at here our u will be 2x. When we differentiate it, it will be 2. And then our dv over dx equals to sine x. When we integrate our sine x, it will be negative cos x. And we substitute everything to the general formula, and we will have integrate 2x sine x equals to 2x times negative cos x minus integrate negative cos x times 2. And then the final product will be negative 2x cos x minus integrate negative 2 cos x. Now we're going to substitute this answer into the main calculation, which is here. Now we're going to bring this negative 2 out from here, and it will be positive 2. Now we're going to open bracket everything. When we open bracket, it will be x square sine x plus 2x cos x minus 2 integrate cos x dx. When we integrate cos x, it will be sine x. Therefore, the final answer is x square sine x plus 2x cos x minus 2 sine x plus c.